Hi scholars, happy Wednesday. Today we're going to be doing Unit 9, Chapter 5 of Language Arts. It should be May 20th in your packet. So go ahead and get your packet ready and your reader open to Chapter 5. The description below has a link to our digital copy. It starts on page 29. Next up we have our do now. You're going to combine these small short sentences into a combined sentence using commas and transition words. So our three small sentences. Amy returned to the site. Amy removed her knapsack and her tools, and she found the fossil missing. Combine all three of these into one full sentence. Our objective for the day, I can explain the differences between mixtures, solutions, and compounds using text evidence. Mixtures, solutions, and compounds. Our vocabulary, repeat along at home. Our first is the noun mixture, mixture. Two or more substances that are combined without changing their chemical composition. So, you probably have seen someone make mixtures before. If you've ever made a drink at home, if you've ever taken water or juice powder like Kool-Aid and sugar and then combined them together, you're not changing the chemical composition of the Kool-Aid. You're just combining these two different substances into one drink mixture. Dissolve. Dissolve is when you turn something into a solution. So if you've ever seen a chemical or a drink dissolve before, especially if you ever watched a tablet go into like a bottle of water and it like dissolves and bubbles away till you can't see it anymore. We'll talk about what a solution is in a moment. Decompose. Decompose means to decay. So all living things and all organic things decompose over time. So after you're dead and long gone, your body actually begins to decompose or decay away. That's the transition from a human being into maybe a skeleton left behind, but that takes a long amount of time. And then suspicious is an adjective we're all familiar with, giving the impression of dishonest behavior. Take a moment for some word work. What kind of mixture is good to drink on a summer day? What kind of drink might you make by mixing things? And then what behavior would make you suspicious of cheating? So if you think someone might be cheating, what might they be doing that makes it really obvious? Chapter 5 is on page 29 to 34. It's called Sketches and Secrets. The big question while you read along at home, what do the sea and sweet tea have in common? So what does the ocean have in common with sweet tea, the drink? Keep that in mind as you read. You're starting at the top of page 29. It's only 5 pages. After that, I'll pick it up and we'll review our questions, and then we're going to make a chart of rules together to show how to know if something is a solution, a mixture, or a compound. Go ahead and begin now. Next in your packet, you should see these 1, 2, and 3 questions. These are just some basic comprehension we're going to go over so we can list out our different mixtures, solutions, and compounds before we make our rule set. So, what is a mixture? Filling it in. Two or more substances that are physically mixed but can be separated. A mixture is something that you can mix together but you can separate them, so they're not permanently combined. So if you have a PB and J, you combine them two, you can still separate that sandwich. I'm talking about something that you can combine and never can be separated. So a mixture are two things that you can separate from one another. So think of something like juice and sugar. 2. Test says that however you stir a mixture, the physical properties do not change. Name examples of physical properties that do not change. So I want you to, if you looked all the way back at the second half of chapter 1, it talks about the water cycle. So you should mention mass, texture, or other physical properties mentioned in lesson 1. These are things like color, size, dimensions. 3. Imagine a container with sugar dissolved in the water. How can you use the information you learned about evaporation to explain how sugar crystals might be left behind if the container was left outside on a hot day? Remember, sugar does not change states until it's much hotter than a hot day would make it. So, you should mention that water evaporates, water would evaporate, and that evaporation is the movement of water from liquid to gas. That means water could no longer be confined to the container. Sugar is a solid and is left behind. So if you ever actually took a thing of Coca-Cola and you boiled it like on a stove, it'd be really gross. All the Coca-Cola dissolves away, the drink, but at the very bottom is all the sugar at the bottom of the pot. So they can be separated still. The sugar would remain a solid and still be left behind. Going back to our big question then, how is seawater and sweet tea similar? We know that both of them are actually mixtures. So if you've ever been in the ocean and you've gotten out, like they talk about in our chapter, you feel, if you've ever been in the ocean, you come out, the water dries off, but you don't rinse yourself off. Your skin actually dries out from the sea salt still left on your body. It's the same thing with tea. When you make a tea, you put sugar inside of it, but the sugar doesn't dissolve. It's just very tiny particles still inside of the drink. The same with a drink like Kool-Aid or something. So they're both mixtures still. To remember that and atomic bonds, or the bonding of atoms like our elements, we have a rule set right here on the right before we make our own. So let's go through this first one. This is going to show us the difference between a compound and an element. So if you remember yesterday, a compound is when you have more than one type of element in a molecule. So something like fool's gold is a compound because it has 2 sulfur and 1 iron. But gold is not a compound because it's just gold elements and gold molecules in there. So is the element bonded? If yes, is there more than one kind of atom in the bonded molecule? If it's yes, it's a compound. If it's a no and there's only one kind of atom, then it's an element, like our periodic table. Going back to our beginning, is the atom bonded? If the atom is not bonded, is there more than one kind of atom present? If the answer is yes, it's 2 or more elements. So you can have multiple elements, but if they're not bonded, then it's not a compound. They can just be separate. But if there's more than one type of atom present, if there isn't one type of atom present, it's just one atom still, it's still just a singular element. So you can have gold next to silver. It doesn't mean the two are going to combine. These can just be 2 elements sitting next to each other. In a moment, have a pencil ready. We're going to create our own chart to tell the difference between compounds, solutions, and mixtures as well. So you should have that big blank box in your packet that says Tess's rules. We're going to create our own rules for distinguishing between a mixture, a solution, and a compound. So when you're done copying this chart down, I want you to take a photo and send it to me. We're going to start in the top left of our chart. When I mix two substances together, do their physical properties change? So let's start with mixtures first. When I mix two substances together, do their physical properties change? No. Can I separate these separate substances even if it takes a long time? Yes. I've created a mixture. So it sounds crazy, but you actually could go to the ocean and separate all the water from all the salt. It would just take you forever, but it would be possible. If it's not possible to separate the two, then it's likely a solution. That's something that they've been combined and you cannot separate them ever again. So think like someone taking a pill, putting it in a bottle of water, and it bubbles up and it's gone forever. Let's go back to the beginning. When I mix two substances together, do their physical properties change? If their physical properties do change, you've created a compound. If you're unsure, it kind of has a big box right there, measure the mass. Let's look at this one rule. Measure the mass of each substance before you mix them. So you might be measuring your two different elements, then measure the mass of them together. If the combined mass is changed, you've created a compound. So if you have one mass with an atomic weight of 1 and another with an atomic weight of 1, and you combine them and it's 2, then you've created a compound. If it's no, it's going to take us back towards the top, and it's either going to be a mixture or solution. If you're unsure, it's going to ask, when I heat the substance, is a solid left behind? If yes, think of this boiling Coca-Cola and the sugars at the bottom. If the answer is yes, it's likely to be a solution. If no, it's not likely to be a solution. And if we've gotten all the way to that bottom right part, this is a very weird circumstance that it's probably not going to fit in any of our categories easily. We're not going to really see any of those in our reader. Now that you've finished the rule set, take some time to double check it. Snap a picture of it and either text or email it to me. You have my phone number and my email in your packets. In the meantime, I look forward to getting those from you scholars. If you have any questions or concerns, please text, call, or reach out to me. In the meantime, stay safe, and I will see you later. Bye-bye.